Okay, in this video today we'll be looking at a partial fractions question where we'll need to use long division in order to obtain the correct answer. Okay, so the question would read, we have to rearrange this algebraic fraction into an expression that does not involve an improper algebraic fraction and then into partial fractions. So you can see here with my question, this will be my question that I'll be using today. You can see the highest power on the numerator is cubed, which is higher than the highest power on the denominator, which is squared. Okay, so that's why we have an improper fraction. So in order to rearrange this, we will need to use algebraic long division first to get a fraction that has a non-improper properties. Okay, and then hopefully we can then use that to split into partial fractions. So let's look at how we would do long division first. So to start off with, okay, I am going to divide x cubed plus x squared minus 7x minus 25 by x squared minus x minus 6. Okay, this will be my answer for the top part of my my long division. Okay, you'll get that at the end. I'll show you how. Okay, so just remember that it's always a good idea to put your correct bit up there. However, in order to start cancelling this out, okay, we do it one power at a time. Okay, we've seen this process before, so I'm going to multiply this by x in order to get this to become an x cubed, and then everything else by x, and then do a subtraction. So I'm going to do that first. So if I multiply everything by x, I'm going to get x cubed minus x squared minus 6x. I'm going to take that away from what I had initially. If I do that correctly, what I am left with is 2x squared minus x minus 25. Okay, I can still continue because I can now cancel the x squared here. If I multiply this by 2 and do a subtraction, I will be able to cancel the 2x squared. So that is my next task. Multiply everything by 2, so that will give me 2x squared minus 2x from there, minus 12 from the minus 6. I'm going to do a subtraction, and the 2x squared will cancel, and what I'll be left with is x minus 13. Okay, now I can no longer cancel that. The highest power on this is just x to the power 1. I would have to use something here with an x squared as the highest power. I will not be able to cancel that, so that's where we stop here. So remembering that we have a remainder of x minus 13 we cannot cancel, how this would look if we use long division is this fraction would become x plus 2, which was what my answer was at the top there, plus a fraction of x minus 13 divided by a denominator which we originally had. So now we have got this split up into fractions where there is no improper fractions. Okay, it did say now try and use partial fractions in order to simplify this even more. Okay, so we're going to be looking at this bit here to see if we can split into partial fractions. Okay, so looking at this bit here, right, we can see the first thing we need to check is, can this denominator be split up? Can this denominator be factorised? That would help us a lot. Okay, the good thing for us is it can. Okay, it can be split up into x plus 2 and x minus 3. Okay, and that's going to be our factors for this question. So we split them up one at a time. A over x plus 2 plus b over x minus 3. And we're going to look to see what a and b were such that we would get this if we added them together. Okay, so that's where we're at just now. So this is more like type 1 that we've seen. Okay, in order to combine them, okay, a bit of algebraic multiplication there. Okay, we now have the denominators the same, so now I'm looking at the numerators to try and solve. Okay, so I'm now looking at this here in order to see if I can work out what my values of a and b were now that my denominators are the same. So again, if we remember the process, we now substitute values of x into here such that one of these constants will disappear, and we can then obtain the answer for the other. Okay, so I'm going to start off by letting x equal negative 2. That's going to get rid of this bracket here, change that to a 0. Therefore the b will have no impact, therefore the b will disappear, and I'm going to look to solve for a. So if I let x equal negative 2, on the left hand side that will give me negative 15. Okay, in this bracket here I'm going to get negative 5, so I'm going to get negative 5 lots of a. And if I solve for a becomes 3 there. Okay, so I've now used that to solve for a. I can now find another of one of my constants, b this time, by trying to get the bracket attached to the a to disappear. So I'm going to let x equal 3 in this case. That will make this bracket disappear. So if I let x equal 3, that will become negative 10 on that side. That will become 5 in that bracket. This bracket disappears, which means the a disappears. 5 lots of b I've got on the right hand side there. So negative 10 equals 5 lots of b. And if I solve for that, I get b equals negative 2. So I've now found my two values, therefore my initial question could be split up even further than what we'd done in the first slide, okay? And the answer would look like this here. So remembering that was my answer from the long division part, and I'll be able to split my remainder using partial fractions. Okay, this is a very important tool that you'll see used a couple of times during the course, where we use it for integration and also to look at curve sketching as well. Okay, thank you.